Hello and welcome to It's Science. Today in It's Science we are going to discuss two basic laws of physics. One is Newton's third law, which tells that each action has equal and opposite reaction. And it is believed that this is true everywhere, in every circumstances it holds. Second is a law of electrostatics, which states that when two charges are there, they are not moving. When two static charges are there, they exert force on each other, and that force is governed by Coulomb's law, which tells that the magnitude of the force depends on the product of the magnitude of the charges. It increases when the magnitude of charge increases, and it decreases when the separation distance between the two charges decreases, because the force varies inversely with 1 by r square, where r is the distance between the two static charges. Now we have two charge. This is Q1, this is Q2. For example, what if one charge moves? For example, initially take the distance between the two charges as 1 light year. Now 1 light year is a distance which tells us that light with a speed of 3 × 10⁸ meter per second in vacuum travels in 1 year. So initially let us assume that these two charges are separated by 1 light year distance. Now when these two static charges are separated with a distance of 1 light year, and if this charge moves a little bit towards this one, will the Coulomb force changes instantaneously? This is the first question. Second question is, initially when they two are at rest with a separation distance of 1 light year, this is exerting a force of Q1 Q2 by r square. This is also exerting a force on this in the opposite direction. Magnitude is same, Q1 Q2 by r square. So Newton's third law holds between the two charges. But what happens when this charge moves a little bit further towards this one? To answer this phenomena, the concept of field was introduced. That's why when we go through our physics textbooks, immediately after the Coulomb's law, you will find the concept of field. Field is, suppose I have a charge of magnitude Q, then its neighborhood in which its influence exists is called the field of this charge. So when the two charges are separated with a certain distance and they exert certain force on each other, they are basically into the field of each other. Initially, when these two charges are separated by a fixed distance, they are into the field of influence of each other. And when this charge moves towards this one, this is an information that the position of this charge is now reduced. Interaction between two charges is basically a two-way process. First, a charge, say Q1, creates an electric field in its neighborhood. And when another charge Q2 is placed in its electric field, the electric field produced by Q1 exerts a force on Q2, which is Q2E. Similar thing happens when Q2 creates its own electric field E prime, which exerts a force F2 on Q1, and the force is equal to F2 equal to Q1 E prime. We know that no information can travel with a speed greater than the speed of light in a vacuum, which means this information that the position of this charge is now shifted will take at least 1 year to reach this. So this is now experiencing a new force because now the separation distance is reduced. But this one has yet to receive the information that the distance is now changed. So this one is experiencing the same force as before. And during this 1 year, the Newton's third law is not valid at all. And in 1 year, when the information that this position is now shifted reaches this one, this again experiencing a new force. And this force is now same as experienced by this one due to this. So during the 1 year, the Newton's third law is not valid. After 1 year, it is valid again. Please let me know in the comment section below how do you like the video. Thank you very much.